Hi, all of you. Hope you're doing good. Welcome back. My name is Adil Khan. I'm your chemistry teacher in Base Education Services Private Limited. So this is the third session for introductory or the bridge course for standard 11th. So before we start today's session, let's discuss the questions which I have given you yesterday as your home assignment or homework. So these questions are from the valency and the formula, the chemical formula which you need to write of the molecules. So calcium hydroxide is CaOH whole twice. I hope you got this right. And sodium phosphate Na3PO4, zinc sulfate ZnSO4. Accordingly, you can see this and find out the answers from here. These are the answers. If you have got 10 on 10, then it means that you have done exceptionally good. You have understood what I wanted to convey you in my previous lecture. If you got 9, 8, then you are still done some decent work. And if you got less than that, then trust me, dear student, you need to put extra effort to increase to make your basics strong in chemistry. So I hope you have understood this. If you have doubt in anything, you can ask on the Cubase platform. So sodium bicarbonate is Na plus and HCO3 minus. So this is sodium bicarbonate. Bi means hydrogen must be there. So these are the key answers of the previous class question which I have given to you. So let's move to the next session. This is the session number 3 for which course. So what you see, you must be tempted. I'm not going to teach you cooking and all. So the topic of today, you can find out from here. So what you see here, it is bhel, right? This is bhel, which most of us like to eat, having a tangy flavor. So when you see bhel, bhel is made up of tomatoes, it is made up of onion, it is made up of puffed rice, masalas, chutneys. You mix everything and you eat it. In short, you call bhel as a mixture. So you guessed it right, that today's topic we are going to start is mixture. Now, few things I want to tell you keeping in mind bhel before I go into the content of mixture. When you mix puffed rice, tomatoes, onion, coriander, chutneys, you see that they are just mechanical mixture. They don't react. The onion do not go and react with tomato. The puffed rice will not react with coriander. There is mechanical mixture. You just mix it, it is ready. First point. Second point, there is no fixed proportion. For example, I don't like onion. So I will tell my bhel puri wala that Anna, you give me less onion. Okay. Someone like more onion, they don't like tomato. So they give less tomato. Someone tell, don't give me coriander. Someone tell, don't give me khara chutney, give me only sweet chutney. So there is no fixed proportion. Third, if suppose they have given, suppose I don't like onion. If they have given accidentally onion, what I will do? I will use my finger and throw the onion out and eat the rest of the thing. So using this bhel, whatever you don't want, whatever content or whatever constituent or whatever part which you don't want, you can remove by mechanical hand or any mechanical process. You can use spoon also or fork also to remove it. And next is, inside bhel, onion remain onion. The taste of onion remain exactly like onion. The taste of potato or tomato, whatever you add, it will remain same. It means that the constituent particle means the particle bhel made up of do not change, it remains same. So these 4 golden points you need to remember for mixture. I'll repeat again. The first point is there is no chemical reaction taking place when you make bhel. Second, there is no fixed proportion which is present there. Okay, there can be more tomato or more onion. Third, you can separate the constituent particles by mechanical method like hand picking and all. And next, the constituent particle retain their property, means onion remain onion, tomato remain tomato. They will not, onion will not become paneer and tomato will not become potato. I hope you got the basics from here. If it is so, let's move into the topic. But first, let me remove Mr. Bhel from here. So I need to reduce the size of Bhel. Just a second. Okay, I can put it up. So Bhel gone. Okay. So we will be discussing this Bhel. Let's go up. So let's start the third session of bridge course, that is mixture. So in this session, we are going to study some important concepts of chemistry which will build our foundation. On that, we will build your chemistry pillar and skyscrapers. We'll study about mixture, type of mixture, we'll study about compounds, then we will study about physical and chemical change, we will study about atomic and molecular mass and some problems on that. So this is my plan for the day. So let's start. So as I said, mixture, everything what I explained, it is here. So mixture consists of two or more substances like bhel. You can take example puffed rice, tomato, potato, onion, whatever you have. They can be element or compound which are physically mixed. So there is no chemical reaction or interaction at all. And they are mixed in any proportion by mass. The proportion is not fixed. If you want onion more, you can add onion more. That is the concept. And the properties of the mixture are same as the property of the constituent. So the bhel what you produced, overall, the taste of it is the taste of all the component what is present. And the constituent of the mixture can be separated by simple physical method. In case of other mixture, you can use hand picking, mechanical separation, gravity separation, anything, magnetic separation you can use. These are the basic point about mixture. Physically mixed, no chemical reaction, the constituent particle retain property and they can be separated by the physical method. Now mixtures are of two types. You can see the example of this. So this is water having salt inside it. So this is nothing but you can call it as a salt solution. Salt is a common salt, table salt, NaCl what you use. So you take NaCl, mix into it. You cannot see NaCl inside it when it goes inside. Before you can see the white color NaCl. But when you mix into water, it is dissolving inside it. You cannot see the difference between water and NaCl. So these type of solution or mixture is known as homogeneous mixture. Homo is the Latin word which means same and genus is a substance. So same type of substance you can tell. Similarity. This is mud water. You take mud. This is the rainy season. So you can see mud water on the road also. You take mud, add into glass and mix it. What you see, mud, most of the quantity or majority of the mud amount will be settled in the bottom under gravity. The finer mud particle will be floating all over. So more mud content is in bottom and less is at top. So you can clearly see two distinct layers at the junction or bottom of this glass. So this is an example of your heterogeneous substances or heterogeneous mixture. So homogeneous mixture in short is the composition is uniform throughout. On top of the salt solution, if you drink, it is salty. Bottom also, if you taste, it is salty. But top of this and bottom of this, there is a variable or variation. So heterogeneous mixture composition is not uniform throughout. It is variable. Example of homogeneous mixture is sugar solution. You make sugar solution, you add rasna into it. Rasna, you know, right? So the top layer of that will taste same, bottom also taste same if sugar is uniformly mixed. Okay, if sugar is sitting in the bottom, then the taste will be different. Bronze you can take. Bronze is nothing but it is an alloy. Alloy is what? You take two metal, mix it, you melt it and mix it under some composition, standard composition or slight variable composition, you will get bronze. You will get alloy. Bronze is the mixture of copper and tin. Two metal melted and added. If I'm not wrong, tin percentage, how much we add with respect to mass is 12 to 14% by mass. For example, if I am adding 88 gram of copper, I will be adding 12 gram of tin. So the product produced, the alloy, will be having both the metal properties. Heterogeneous mixture example is iron filling with sulfur powder. Suppose you take an iron filling with sulfur powder, how to separate them? Take a magnet, put on the top, all magnet is attracted, or sand and sugar or clay you can tell. So this is about mixture and its type. Now let's study difference between compound and mixture. In the first session, when I have given you classification of matter, I told that matter is classified into physical and chemical, and even I said it is pure substance and impure substance. Compound, when you see, it is a classification of your pure substances, whereas mixture, when you see, it is the classification of your impure substances. So pure substances and impure substances. Okay? Compound belong to pure substances category and mixture belong to impure. Now, this is the diagrammatic view of compound and mixture. This is compound. This is nothing but your sodium chloride, salt. And this is your jelly beans, or you can tell the beets, color beets. This is the mixture. Now let's come up, then we will come down. We'll see the content, then we'll see the diagrammatic part. Compounds, the constituent are present in fixed ratio by mass. For example, if I take water, I have given this example, I'm taking carbon dioxide. Now carbon dioxide, you consider from India, or you go to Uganda, or you go to Zimbabwe, carbon dioxide formula remains same, CO2. Now carbon mass is 12 and oxygen mass is 2 into 16. So 12 is to 32. The simplest ratio when you find out, so this is 6, 3 is to 8. So carbon and oxygen always combine in the ratio 3 is to 8, whichever country and wherever it is formed. This is the meaning of constituent particles are present in fixed ratio by mass. Mixture, constituent particle may be present in any ratio. Remember the Bhelwala example, you can understand this. Compound lost the property of the constituent. Okay, when compound is formed, the property of the constituent is lost. For example, if I take water, water is formed by hydrogen and oxygen. I'm not writing in the balanced form now, I'm just writing the constituent. Hydrogen is a gas, oxygen is a gas. Okay, they have different nature. Oxygen is known to cause combustion, burning, or heating, whereas water is a liquid. So two gas combine to become liquid. So gas loses its identity. So that is the meaning of loss of properties. But here retention of property of the constituent. Remember Bhel example, potato remain potato, onion remain onion. Third, constituent cannot be separated by simple mechanical method. Suppose you take glucose example, C6H12O6, this is your glucose. Now, if you want to remove 6 hydrogen to make it C6H6O6, simply if you want 666, you cannot do that. That's not possible. Or if you take water and you don't want hydrogen there. No, I don't want hydrogen. I only want oxygen in water. You cannot do that. You cannot take water with your finger and remove one of the hydrogen. It's not possible. That's the meaning that constituent cannot be separated by simple mechanical method. Whereas mixture, you can separate by simple mechanical method. Take up Bhel, remove onion, remove tomato, no one can stop. Fourth point, compounds are formed due to chemical changes or chemical reaction. For example, if I write water production, so I write hydrogen, H2, I write half O2. What I get water. With this, some energy is leaving. I will tell this later. This is water. this looks simple, but it is not that simple. It's a very complicated reaction, production of water. So this only takes place when some chemical reaction happens. Chemical reaction means old bond will break and new bonds will form. Bonds in reactant will break and bonds in product is formed. Whereas mixture, they are just mechanical mixture. Neither bonds will break nor bonds will form. And the last point, suppose they have sharp melting and boiling point. Suppose I take ice as solid, that is H2O solid. You know that its melting point is 0 degrees Celsius. And water, if I take as liquid, its boiling point is 100 degrees Celsius. If there is a pure water, boiling point is 100 degrees Celsius. If there is a pure ice, its melting point is 0 degrees Celsius. But in case of mixture, no sharp melting and boiling point. Reason for that, onion, tomato, bhel, and the puffed rice and all, they have their own melting and boiling point. So when you melt it all together, there will be a range of melting and boiling points. Suppose tomato melt early, onion will melt later. So it need a range of the melting point. So this also tells about purity and impurity. A pure substance, melting and boiling point is fixed. For impure substance, melting and boiling point is variable or it has a range. For example, if in water, I add sand or salt or sugar, its melting and boiling point changes. The boiling point of water, if I add sugar to it, will increase and the melting point will decrease. That we will do next year in solution chapter. So this is the difference between compound and mixture. I hope this is clear to you. Most of us have confusion in this portion. I believe here onwards, this is crystal clear to you. Got it? Moving to the next slide. Let's talk about physical and chemical changes. Very important. You read in your lower classes also, but student like me, average type, we get confused with this. Basically, what is change? So when one or more property of a substance is altered, then it is said that a change has occurred. Okay. There are two types of change, physical change and chemical change. Physical change is what? No new substance is formed. For example, you take wood, suppose this is the scale, and if I break this scale into two halves, it still remains the wood. So no new substance is formed. And in chemical change, new substances are formed. For example, you take milk, add little amount of curd, next morning entire thing is converted into curd. So milk is not milk now, it becomes curd. That is new substance formed, that is a chemical change. Physical change is temporary. Okay, it is temporary for some duration of time. I will explain with example. And chemical change is permanent. For example, milk once formed into curd, transformed into curd, you cannot tell curd please become milk again. It's not possible. So that is permanent, and physical changes are temporary. Third point, physical changes are reversible. You can reverse it. Reversible, you will read later that the symbol of reversible is this. Whereas chemical changes are irreversible. You cannot ask curd that become milk again. That's not possible. So example of physical and chemical changes are, physical changes is the cutting of the wood, what is present here, wood plank or big wood block. And chemical changes are your burning. This is physical, and chemical is the burning of the wood or burning of the charcoal. It will give you that example. Physical change, if I take few more examples, for the most controversial example when I was in school is burning of candle. In burning of candle, if I tell melting of wax, wax melt, it is a type of your physical change, because wax you will have, again you will retain back. But if I tell burning of candle, when candle burns, suppose this is your candle, when candle burns, it will give out something known as black color soot. You can try this in home today. Take a candle, burn it, and on top of that put a metal plate or a steel plate, you will see that the steel plate will become black. That is known as soot. This is nothing but hydrocarbon made up of hydrogen and carbon. So burning of candle is your chemical change, whereas melting of the wax is your physical change. One more thing I will tell, between all these 3 points, the most important point is the first one, new substance form and no new substance form. Reversible and irreversible is not that strong and convincing point. Reason for that, suppose you take glass, you break the glass into fine particle or small pieces. This is physical change because the broken glass itself is glass, but you cannot reverse it back. So reversible and irreversible concept is an important difference, but it is not the most important one. The most important is new substance form and no new substance form. Okay. I'm telling you a few of the examples. You need to classify that into physical and chemical. For example, formation of dew. If you see India cricket match and if you see Mr. Irfan Pathan doing commentary, then Mr. Irfan Pathan tell dew as sabnam. In Urdu, dew means sabnam, okay? Dew drops generally in winter time on grass. You can see that on your window pan, you can see that. The formation of dew is what? Physical change or chemical change? PC or CC? What? PC, absolutely right. If I tell evaporation, you know, right? What is evaporation? Evaporation is when you wash cloth and keep it outside, hang it outside, it gets dry. It's physical or chemical? That's right, it is a physical change. Suppose I talk about burning of wood. Suppose you burn the wood, physical or chemical? Burning of wood, chemical change. Cutting of wood, physical change. For example, electrolysis of water. Water breaking in presence of current. Electrolysis means, electro means electricity and lysis means break. So electrolysis of water again is chemical change. I hope that is clear. So you got to know the difference between physical and chemical change. Very good. Let's move to the next slide. Now, I give you an example of milk getting converted into curd. So suppose I write milk and it become curd. So here I can tell a reaction is taking place. Reaction means what? When some changes you can notice. Milk is basically a liquid and curd is a semi-solid. So you can write it as a solid only. So there is a change in the physical appearance, there is a change in the taste, there is a change in the consistency and various other forms. So what is a chemical reaction? Basically in chemical reaction is representation of a chemical equation. Okay, chemical equation I will explain. What is chemical equation? It is a shorthand representation of reactant and product using symbol and formula. For example, if I take carbon and I take oxygen, when I heat carbon, so that I burn it, delta means heat, I get carbon dioxide gas. Okay, carbon basically here is graphite, so it is solid. This is your gas and this is your gas. So this is the example of your chemical equation. So you write reactant on one side, product on another side. According to convention, convention means what we follow. Reactant are written on the left hand side and product on the right hand side, and in between them we put an arrow. This arrow means yield, okay, yield. This also tells us the direction in which reaction takes place, from reactant side to product side. You can write product here and reactant here, that is also possible, but by convention we follow this. Okay. So chemical reaction basically is representation of a chemical equation, and chemical equation is the shorthand representation of reactant and product using symbol and formula. You can also call chemical equation as mathematical representation, because Balancing, you do number, you use. So mathematical representation or mathematical statement of reactant and products, which is present there. Okay. So let me give this example. For example, if I take production of ammonia, I take nitrogen, I take hydrogen. When both of them combine, it will give rise to ammonia. Now you have to balance it. Balancing you would have done in 10th standard. So how to balance? So 2 times, and this is 3 times. So 6 hydrogen, 2 nitrogen, 2 nitrogen. This is your chemical equation. Next point, remember that a chemical equation, this is the balanced chemical equation, is always balanced with respect to law of conservation of mass. Now what is LOCM? LOCM is law of conservation of mass. Let me give you a layman example. Suppose I take half kg of rice and I add half kg of curd. How much curd rice you will get? You will get 1 kg. Half kg of rice and half kg of curd give 1 kg of rice. This is known as law of conservation of mass. How much reactant you will use, that much product you will get. But exceptions are there like radioactivity and all. So I'm not going there. How much reactant you use? So you can, in short, you can write mass of reactant is equals to mass of product formed. If half kg of rice and half kg of curd is giving you less than 1 kg of curd rice will be very costly. No one will eat it. If half kg of curd and half kg of rice is giving you 10 kg of curd rice, then restaurant business is the most profitable one. So these two cases not possible. Half kg curd, half kg rice will give you 1 kg of curd rice. That is law of conservation of mass. So any chemical reaction and the equation what you write always follow this law. Okay. Why it follows this law? So that the number of atom of each element on reactant side is equal to the number of atom on product side. So here 2 nitrogen atom. I cannot use, okay. So here 2 reactant hydrogen atom, here 6 hydrogen atom, here 2 nitrogen, and when you multiply this 6 hydrogen atom. This is the balancing which you get here. Suppose I give you combustion of methane. So you take methane and heat to burn it. Always remember that whenever you heat an organic compound, you get always 4 products. Carbon dioxide, you get water vapor, and you get heat and light. We will do that later. Can you balance this, please? First, so this will be 2. And this will be 2. So 1 carbon, both the sides balanced. There is 4 hydrogen balanced. There is 4 oxygen and 4 oxygen that is balanced. I hope that is clear. So that's all about your chemical reaction and chemical equation. So chemical reaction and chemical equation, you can also call chemical equation as mathematical statement of reactant and product. This is one part of the lecture which we were supposed to discuss today. Other part is atomic mass and the molecular mass. Okay. So let's take a couple of second break and we will start it. Okay. Let's start. To understand chemistry or to understand a building, a house, how strong it is or how weak it is, you need to understand which quality of brick you have used along with the cement. If you have used good quality of brick and good quality of cement, definitely your house will be stronger. Similarly, in order to understand chemistry properly, you need to understand atom. Okay? And to understand atom, you must know about its few fundamental properties. The few fundamental properties of atom, like its atomic mass. When you go to market, suppose you go to market to buy mango season was there, and you tell the shopkeeper that you give me mango. Shopkeeper will do what? He or she will keep an iron mass here. This is 1 kg. In physics, in unit and measurement, you will get to know that there was a group of people who decided 1 kg will weigh this much. They have a standard kept. Now, simultaneously, they will keep mango here. Now, if this line is straight, it means that the mango also is 1 kg. If you want apple, same thing they do. If you want grape, same thing we do. So what I want to tell you here is, if you buy mango, apple, grapes, or potato, tomato, you get a relative mass. One iron bar is kept, this side mangoes are kept. If they are equal, we tell it is 1 kg. It is relative mass. You are relating with someone. For example, if suppose my brother gets 95 percentile in boards and I get 85 percentile, then I am related. He got 95, you got 85, he got 95, 85. This is relative. So I'm always related with his performance. Okay, same thing is relative atomic mass. So in case of macromolecule, means bigger objects like mango and all, you find out relative mass. For smaller substances like atom, you also find out relative mass. Exact mass is difficult to find out. The reason for that, atoms are very small and very light in weight. So just like to find out mass of a bigger object, you use relative unit. Here also you will be using our relative unit. There the relative unit is kg. Here we will see what is that relative unit. Now atoms and molecules are too small and they are too light in weight. So scientists realize that they cannot weigh it directly and find out its mass. So best way is to express such small masses using relative scale. Relative means to compare the masses of atom. Mass of one atom compared with something. In case of mango, there is a solid iron bar which is standardized. For atom, what to do? Scientists initially came with an idea to take hydrogen as the standard reference. But later, we removed it because it is a gas. You cannot have a gas to weigh something easily. It is difficult to weigh. And second point, it is inflammable. It catches fire. Due to these two reasons, it was not used after some time. Later, scientists came to a conclusion and they started using your carbon as the standard to measure atomic mass. Okay. Now, carbon symbol is C. Carbon C, capital C. They have atomic number 6. And your mass number is 12, 6, atomic number, mass number 13 and 14. So they are isotopes. So carbon has 3 isotopes. Scientists, they have selected carbon 12 isotope. Reason for that, it is a solid and it is abundant, available in larger amount. Okay. So for expressing the atomic mass on relative scale, carbon 12 as an isotope of carbon. Isotope means what? They have same atomic number but different mass number. We'll do that later, but this much, only this much. At this time, only this much. It is SANI. SANI means same atomic number isotopes. Okay. So for expressing atomic mass, relative scale is used. Carbon 12 isotope was selected as the standard and assigned a mass of 12. Mass 12 is assigned. This is, we are talking around 1860. That time mass was assigned 12, keeping in mind atomic number and 1. Later, when mass spectrometer, this is an analytical chemistry tool, was developed, we found out the exact mass of carbon. We will discuss that later. So assign the mass of 12, hence atomic mass unit, short form is AMU, is defined as 1 by 12th. So you can write it as 1 by 12th of the mass, 1 by 12th of the mass of 1 carbon 12 atom. So 1 by 12th mass of 1 carbon 12 atom. So this is nothing but AMU, atomic mass unit. Okay. Now, This is, let me give you slight more about this. Just a second. Okay. So this is your AMU. So AMU, just now I told that it is nothing by 1 by 12 into mass of 1 carbon 12 atom. And with respect to this, the relative atomic mass of other elements were found out. For example, if I write mass of 1 nitrogen atom, so this can be written as, you know, it is 14 into 1 by 12 into mass of 1 carbon 12 atom. So 12 and 12 will cut, it will give you 14 only. Next is mass of 1 oxygen atom. So we can write it as 16 into the same thing what I have written above. Suppose I write mass of 1 sodium atom, Na, natrium, mass of 1 sodium atom. So you can write it as 23 into the same thing what I have written above. Now, since this is repeated frequently, this 1 by 12 is repeated frequently, what they did, this entire thing they considered as a unit, a very small unit, and that unit they called it as AMU. So from here onwards, if you write mass of 1 nitrogen atom, so you write 14 and replace 1 by 12 into mass of 1 carbon 12 as 14 AM as AMU. Here you write it as 16 AMU, and here you write it as 23 AMU. So AMU is what? It is 1 by 12 of mass of 1 carbon 12 atom. And this one is the smaller unit of atomic mass. Atomic mass has various units like Dalton, unified mass, and AMU. So these are the things. So I hope this is clear. Any doubt here? Very good. Now, you know, atomic mass unit is defined as 1 by 12th of the mass of carbon 12 atom. Let me change my pen color. Okay, now on this basis, atomic mass of an element, it is a ratio of the mass of one atom of the element. For example, mass of 1 hydrogen, 1 H, 1 O, you can write 1 hydrogen, 1 oxygen, or 1 nitrogen. That is the meaning of that. To 1 by 12th of the mass of carbon 12 atom. So atomic mass, this is the formula, okay, which you need to know. Atomic mass is mass of one atom of the element. Element is important. And 1 by 12th of the mass of carbon 12 atom. So 1 by 12th, you know, I have explained it is 1 AU. Molecular mass are also expressed in terms of your atomic mass unit. Atom, you know, suppose atom is your hydrogen and molecule is H2. Atom, suppose oxygen, molecule is O and O2 and O3, ozone and oxygen. This is, we are going to discuss now. Atom done, molecule, let's move. So the relative, again, molecular mass exact, it is difficult at this point of time to find out. The relative molecular mass of a substance, not an element, before it was element, is the ratio of mass of one molecule of the substance. Previously it was one atom of the element. Here it is one molecule of the substance. See the difference? Bottom it is same, 1 by 12th of the mass of carbon 12 atom. Got it? Now molecular mass of a molecule thus represents the number of the time it is heavier than 1 by 12th of the mass of one atom of carbon 12. In a simple word, molecular mass means a molecule will have a mass into, mass by this times. So just remember this formula. It will help you to identify the or find out the mass of molecular mass of a molecule. mass of one molecule of the substance by 1/12 of the mass of carbon 12 atom. Okay. Later, with the help of mass spectrometer, we got to know that mass of one atom of carbon 12 or one atom of carbon 12, one value it got, that is 1.99 into 10 to the power minus 23 grams. And using that, one AMU also value you got using mass spectrometer, that is your 1.67 into 10 to the power minus 24 gram, or you can write it as 1.67 into 10 to the power minus 27 kg. So this is one AMU. Later, using mass spectrometer, we found out this. When you come to class, we will show you inside that classroom. Okay. Now let's go and talk about molecular mass. Now, the last statement, what you have read here, molecular mass of a molecule like O2, N2, O3 represents the number of time it is heavier than 1/12 the mass of one atom of carbon 12. Example, molecular mass of hydrogen. If you take H2, one hydrogen is 1, another is 1, so it is 2. This indicates the mass of hydrogen molecule is twice means 2, this 2, of 1/12 of the mass of carbon 12 atom. Similarly, molecular mass of water is 18. I will tell you how to find out, or let me tell you now only. To find out molecular mass, you have to take atomic mass of each atom. So it has 2 hydrogens and it has 1 oxygen. So 2 into 1 hydrogen atomic mass is 1, and this is your 16. So 2 plus 16 equals to your 18. So that's why we write molecular mass of water is 18. This indicates the mass of water molecule is 18 times heavier than 1/12 of the mass of carbon 12 atom. Suppose I write ammonia. I have to do this, so let me give you some other example. Suppose I write nitrogen, N2. The mass of this is 7 plus, the mass of this is 14 plus 14. It will be giving rise to your 28. Okay, so 28 times it will be heavier than your 1/12 of the mass of carbon 12 atom. Clear? Any doubt? Good. Now, this you need to know. This is the most important point. Question will come from here. Before this was just a content part. So the molecular mass of a substance is you get by adding atomic masses of all the atoms present in the molecule. I'm solving few questions. You understand that, and the concept will be clear. So question is, calculate the relative molecular mass of the following compound: ammonia, sulfuric acid, and hydrated copper sulfate, CuSO4.5H2O. So this is also known as your blue vitriol. So this is your blue color solution when you add it to water. So let's find out. So mass of ammonia, how to find out? So when you find out molecular mass of ammonia, there is 1 nitrogen atom and there is 3 oxygen atoms. So when you take ammonia, so nitrogen atom is 1 time and hydrogen is 3 times. So you write 1 into atomic mass of hydrogen plus 3 into atomic mass of 1 into atomic mass of nitrogen and 1 into atomic mass of hydrogen. Nitrogen, you know, it is 14. So 1 into 14, and this is 3 into 1. So 14 plus 3 equals to your 17. This is the molecular mass of Mr. Ammonia, not Mr. Ammonia. H2SO4, when you take, so to find out the molecular mass, you need to find out atomic mass of each element. It has 2 hydrogen, so I will write 2. It has 1 sulfur, so I will write 1 sulfur. It has 4 oxygen, so I will write 4 oxygen. So hydrogen, you know, it is 2 into 1 plus 1 into sulfur. Sulfur is how much? 32 plus 4 into 16. So this is 2 plus 32 plus 64. So when you add 64, 66, 68 and 9. So 98 is the molecular mass of your H2SO4. king of acids, sulfuric acid. Okay. Next one is hydrated copper sulfate, USO4.5H2O. So molecular mass, what we write it here is, so this is copper sulfate dot 5H2O. So there is one copper, there is one sulfur. Total how many oxygens are there? Don't mix 4 and that side, okay? That we will write separate. So there is 4 oxygens here. And there is 5 water. Now water till now you know it is 18, so I will keep it as 18. Copper is 1 into 63.5, sulfur is 1 into 32. Water, oxygen is 4 into 16, and water is 5 into 18. When you add up everything, you will land at 249.5. Understood? So this is the way you need to find out molecular mass of a given molecule. So 5 water, so you will take 5 into 18. If it was 7 water, you will take 7 into 18 and accordingly. I hope this is clear. Let me give you one more. As which one I should give it? Okay. Suppose let's find out molecular mass of carbon dioxide. So there is 1 carbon and there is 2 oxygen. Carbon how much? 6 into double, 12. That's right, 12 into 1, 2 into 16. So this is 12 plus 32. 12 plus 42, it comes 44. Clear? So that's all from the molecular mass. And the question of the day, this will be a homework for tomorrow. Calculate the molecular mass. Formula mass basically we use for ionic compound. So it means same. Molecular mass or formula mass of each of the substances. So benzene is an organic compound, C6H6 you have to find out. Nitric acid, HNO3 you have to find out. Glucose you have to find out. Chloroform is CH3Cl you have to find out. And sodium carbonate decahydrate you have to find out. Now this is very interesting, which we use in our day-to-day life. Let me know what it is we use commonly in our household function. So tomorrow we will discuss this and do it. Okay. At last, I will do one more for you. Okay, so that it is becoming crystal clear. Suppose I take sugar. What is the formula of sugar? C12H22O11. That's right. So 12 into 12 carbon, 22 into 1 hydrogen, and 11 into 16 oxygen. 12 into 12, how much? 120 and 144. This is 22. So 16 into 11, so 160 plus 16, 176. So 8, how much? 12, 2, how much it is coming? 342. Is it coming 342? That's right. Very good. So this will be the homework, these 5 which you need to do. So do it and we'll meet in next class. One thing you remember, first 20 element mass you must know. So you must know the mass of hydrogen, you must know the mass of helium, lithium, beryllium, till calcium you know, and few more element after that you know. For example, you know of zinc, you know of bromine, you know of iron, manganese, iron, lead, mercury. So few masses you know. So when you come to class, we will let you know. So remember those masses, write in a kg cardboard sheet and paste in front of your study table. Every day see that, you will memorize it. So that's all from today. I hope the concept was clear. Let me give you a summary what we have done. So we have done, started with mixture, bale puri. Then we have seen types of that, homo and heterogeneous mixture. Then we have seen the differences between compound and mixture. I hope that part is clear to you. Then we went and saw 2 types of chemical changes, 2 types of changes, that is physical and chemical changes. Then we got to know about chemical equation and chemical reaction using law of conservation of mass. Then atomic and molecular mass. Atomic mass, you cannot found exact, that's why relative atomic mass you have to find out. Initially, hydrogen was chosen as standard, later carbon 12 because of its abundance and solid. So atomic mass, you know how to find out. Mass of one atom of an element by AMU, 1 by 12 into one carbon atom of carbon 12. And molecular mass, mass of one molecule of a substance by 1 by 12 into carbon 12 wala thing. And then I have shown you how to calculate molecular mass by taking individual mass of all the atoms. That's all from my side. So study well, dear students. Take care of yourself, respect your parents, elders, and be safe. Bye-bye.